Hello. Today we're going to cover this topic called the first and second moment of inertia. Okay, so in this topic there are two main things lah. You have your first moment, or first and second moment of first moment and your second moment. Okay. Let's talk about the first moment first. Okay. As you know, moment is something like force times a perpendicular distance, right? So what the first moment of area, okay, or first moment of inertia is very similar. Okay, it is basically something times the distance. Okay, and it is usually the perpendicular distance lah. And in this case, your first moment of area is not force, but it's basically area lah. Okay, so it's basically an area multiplied by distance. Okay, having know that in mind, right, let's proceed to look at another thing which will be related eventually. You get to appreciate why there is this area times the distance. Okay, we know for all masses, right, you have centers of gravity whereby all the weight is acting on that point. Okay, for simple shapes, like a square, okay, you know that your center of gravity is somewhere around here, okay, whereby is half the height and half the breadth. Okay, for the rectangle you also have something like that. So you know that the centroid, okay, exists somewhere halfway across the length and halfway at the height of the height. Okay, for circle, same thing, you'll be at the center of the circle. Alright, now if you are asked to provide the centroid, okay, the location of the centroid of the center of gravity, okay, you need to give it in numbers, right? And the numbers is represented by x bar and y bar, okay, meaning the location of these points. Okay, but in order to give the value to these x bar and y bar, you have to know where are the x and y axis first. Take for example, if for this square your x-axis is here, okay, and your y-axis is here, then you can give the answer of x bar, right, being this value, x bar. Okay, this is the distance with respect to the axis. Okay, for example, if this square is 10 cm long, okay, so x bar will then be 5. Okay, and then your y bar is this value. Okay, the center of the centroid with respect to the x-axis, that will be your y bar. Okay, so then you can put numbers inside. Okay, 5, 5. Okay, why is this axis so important? Imagine now instead of the x and y you place at the corner here, right? Now you put somewhere else, x, y. Okay, and then you have the same square over here, 10, 10. But now give me the location of x bar and y bar. It wouldn't be 5, 5 already, right? It would be this distance. Okay, this would be your x bar, okay, and this would be your y bar. Okay, so it is instead it is actually 5 plus a certain distance away from the y axis. Okay, so let's make this 6. So then your x bar would then be 11. It won't be 5. Okay, and if this square is above ground, above the x-axis by maybe 7, then your y bar would be 5 plus 7, 12. Okay, that's why the axis where you place it is so important. Okay, in a typical mechanics 2 question, usually they will be placed in this manner. Okay, another possibility is, let's say you have a T-shape beam. they will ask you to find the y bar with respect to the top axis. Okay, means your y, let's say the centroid of the t is here, your y bar would then be this value. Okay, y bar. So I hope I've made myself clear. First, we need to establish the axis first before we can define what is your x bar and y bar. Okay, the centroid. Okay, so these are mostly simple shapes. Of course, except for this t, these are simple shapes. Okay. Of course, the exams will not give you just simple shapes. It will be made up of a more complex shape. Okay, and these complex shapes are usually a combination of simple shapes. Simple shapes. Okay, just give an example. Imagine you have an L. Okay, this is a complex shape, and it is a combination of a few simple shapes. Okay, in fact, there are multiple ways you can see this. Okay, the first way is if you cut along this line, okay, and then you will get one rectangle here at the top and a rectangle at the bottom. Okay, or if you cut along this line, okay, you get a long vertical rectangle followed by a short horizontal rectangle. Okay, or if you're daring enough, you cut along these two lines, you will actually get three shapes. Okay, three shapes. Okay, but of course, rule of thumb, we try to minimize the number of shapes because every shape will incur an additional calculation. So ideally, you would be looking at either this one or this one. Okay, and in fact, there's a fourth one. Okay, it is basically a large rectangle. Instead of adding, right? So you see this plus this plus this. This plus this plus this, instead of adding, you can actually big rectangle minus away this smaller shaded rectangle, and you will still get the L. Okay, so in fact we have 4 combinations to consider. Okay, and you would want to find the centroid of the complex shape. Okay, and that is usually the issue here, because you do not know where is this location. Okay, if I set my x and y axis very clearly, if I set this is x axis, this is y axis, where is this centroid going to be? Okay, this is your job to find, with respect to this axis, what is the x bar. Okay, and with respect to the x axis, right, what is the y bar. Okay, so your job is to find these two values by using a standard equation, okay, that uses a combination of simple shapes. Okay, so what do I mean? The equation goes like this. The area of the complex shape, so we call it total area. Okay, total area, which will be this area here. Okay, this total area, multiplied by the x bar is equals to the summation of the individual shapes. Okay, individual simple shapes, individual area, multiplied by their individual x bar. Okay, maybe we look at this example here. Okay, this first example here. So your total area, this is rectangle 1, this is rectangle 2. Okay, your total area will be A1 plus A2. Okay, A1 plus A2. And this x bar I want to find. Okay, I want to find what is this value here. Okay, it's equals to the sum of individual area and their own x bar. Okay, so for A1, right, I will have its own centroid, right? Because simple figures, you know where is the centroid. So I need to, I can find this value here. Okay, this is what we call x1. okay, the centroid of the simple shape, times x1. Okay, and the second area, okay, plus a2, okay, summation ma, so a1 plus a2 times its own x bar, okay, the x bar of the rectangle 2, so we will call it x2. Okay, so times x2. So from this equation we have a1, a2, x1, x2. So the only unknown we don't have is x bar. So from here you can find the value of x bar. Okay, basically you would transfer this whole area term, right, divide it to the other side, and it becomes the denominator. Okay, so in simple terms it will look like this, plus a2x2 over a1 plus a2. Okay, so this is how you would find x bar. So of course for y bar, right, what's the value here? It will be just a combination of its own area and the individual y value. Okay, y1, and from here it will be y2. Okay, so it will be a1 y1 plus a2 y2 over a1 plus a2. Alright, so this is how you find the centroid for a complex shape that is a combination of simple shapes. Okay, I'll just like to highlight one more point about when your area is a subtraction of another. Okay, because there is a subtraction, it is very important that you need to take note here. You are summing up, right? But you are summing up the negative of this area, so the minus sign needs to be there. Okay, so for example, okay, so let me see. Okay, forget it. So here is the same L, right, equals to the big rectangle minus the small rectangle at the top. Okay, and not forgetting the axis is here. Okay, for each of the individual area, the second rectangle also, okay, it remains the same. Okay, so y bar is here, so y bar is here, so y-axis is here. Okay, and y-axis will be here. Okay, x-axis, y-axis. So let's take a look at the centroid. Okay, let's say the centroid of the whole shape is here. Okay, this is your x bar. Okay, and this is your y bar. Okay, for the big rectangle, of course, it's very straightforward, halfway across the length. Okay, this is your x1, and halfway across the height. Okay, so this is your y1. Alright, for rectangle 2 it's very important because your centroid is here. It's not half the breadth and half the height. It's half the breadth plus this offset distance. So this is the value of x2. This is the x value of the centroid of rectangle 2. Okay, and likewise for y is this whole thing here. Okay, y2. Okay, so once you find this and this, okay, you will then form the equation. Okay, it is basically a1 minus a2. Okay, this is 1, this is 2, right? a1 minus a2 x bar, okay, is equals to a1 times x1. Okay, individual summation of individual. Okay, but this time you know that the rectangle 2 is minus, right? So you need to minus here. Okay, a2 times x2. Okay, so this is the main difference here. You have to be aware of this. Okay, so in actual fact, the the equation will become a1x1 minus a2x2 over a1 minus a2. Alright, so you can do the same for y bar, and you will see. So this is your y2, okay, and this is your y1. Okay, so this concludes the first moment of area. Okay, this concludes the first moment of area, which with this knowledge, then you can proceed to look at the second moment of area. Okay, second moment of area. When we say second, it's something like area times a distance times a distance. Okay, somehow it is a square of a distance lah. Okay, and later you will see how this come to effect. So previously, when you find first moment of area, you realize that it's an area times the distance, right? So this is where you have your first moment of area. Okay, area times distance. But now we're going to multiply it twice. Okay. Okay, second moment of area is actually related to moment of inertia. Okay, moment of inertia. Inertia. Okay, when we say inertia, it's a kind of a resistance, correct? When somebody push you, you don't want to get pushed, right? So you push back, right? So that is your inertia. Okay, you tend to want to stay where you are instead of moving around. So second moment of inertia, okay, this value, second moment, we typically call it I, right? So this I value is a representation of how resistant you are to a motion. Okay, the best illustration is looking at a beam. Okay, imagine I have this long rectangle beam, right? Okay, and it is supported at both ends lah. Okay, by now you should be familiar with this, supported at both ends, and then you have a point load at the middle. Okay, so having a push down, the beam is like this ruler. You're gonna bend like this, right? Okay, so how resistant is this beam going to be against this force? Okay, a lot has to do with this area. Okay, why do I say that? Now instead of bending this beam like this, now you are going to turn this beam 90 degrees. Okay, and you place it on the same support. How are you going to see this? Okay, it will basically be like this. Okay, and then my support now is this way. Okay, imagine the same beam, just tilt 90 degrees only, and now the same load comes down. Okay, do you think the beam is going to be less resistant to bending or more resistant to bending? Okay, you should say that it is more resistant. Okay, because if you see, if your beam is oriented this way, you push it down, you're going to find it very hard to push down. It's going to be very hard to bend, because so there's this inertia law, and it is all because of the change in the shape and the orientation. Okay, and you can prove that the I of this beam, okay, will be bigger than the I of this beam when it is oriented this way. Okay, and we're gonna show you how you're gonna find this I value. Okay. Okay. Simple shapes again. We will usually have a rectangle, okay, and a circle. Okay. In addition to shapes, resistant to motion, we are also interested to know about which axis. Okay. Take for example. Okay, I'm going to show you two examples. If your rectangle is this way, okay, the centroid, is here. Okay, so it looks like this rectangle lah. Okay, this shape resistant when it is rotating like this. Okay, or meaning when it is rotating around this axis, or the shape is rotating about this vertical axis. So in this case it looks like this. So this is the CG again. Okay, so for this vertical case it will be rotating like this. Okay, so the value of I depends on which axis you are looking at. Are you looking at the horizontal axis? Okay, or the vertical axis here? Okay, because the I value will be different. Okay, how different are they? The formula, okay, generically speaking, is 1 over 12 B dq. But the key is where do you take B and where do you take D? Okay, the rule of thumb is the value that you cube, the delta, should be the side that is perpendicular to the axis of rotation. Okay, so take for example, if you are rotating like this, okay, if you are rotating around the horizontal axis, okay, your D will be perpendicular to this axis, which is this side. So this side will be delta, okay, and the long side will be bravo, B. Okay, so as written here, if you rotate this way, okay, your D will be here, this side, this short side. Your B will be this long side. Okay, so this is how you use this formula. Okay, if I now look at the axis, instead of this horizontal axis, I'm turning about the vertical axis. Okay, so this would be the case, right? This would be the case. You're doing this now. So the D is always the side that is perpendicular to the axis. So for your case, this long side will be the delta D, and the short side will be bravo, B. Okay, yeah, so this is how you remember lah. You cube the side which is perpendicular to the axis. Okay, so this is the kind of illustration. For circle, the formula is the same, pi d4 over 64. Why is it the same? Because circle is axis symmetric. No matter what line you draw, as long as it crosses the center of the circle, okay, it is the same. So this formula remains unchanged. Okay, when it's rectangle, then you have to identify where is the B, where is the D. All right. Yeah. So these rotations, okay, are always the rotation axis is always about the centroid of the simple shape. Okay, about the centroid. You see, this axis is actually about the this axis cuts at the centroid, right? What if it doesn't cut at the centroid? Okay, what if it doesn't cut at the centroid? Then the I will be a bit more complex than just this term already. Okay, illustration of how it can rotate away from the centroid. It looks like this. So suppose I have a rectangle here, okay, and you know the CG is here, but now I want this rectangle to be rotating about this line. Okay, I'm not asking for the I when it is rotating about this line. I'm asking you to find the value of I when this rectangle is rotating about this line. Okay, so there is a distance here, there's an offset distance here. Okay, we usually call it H. Okay, the distance away from the main axis, right, of the individual centroid. Okay, so this is the H value, and what this rectangle is supposed to do is to rotate not about here but about here. Okay, so simple illustration. Okay, so I have another rectangle with me. So imagine now this rectangle is this rectangle, the centroid is here, right? And then the axis, its own individual centroid axis is here, right? Okay, but I want to find the eye when it is rotating about here. Okay, so you're actually looking at this, okay, when the rectangle is doing this kind of rotation. Okay, compared to this one, okay, originally here, this one, the eye would be 1 over 12 BD cube. This one will be more complex. Okay, how complex? It's just actually it's just an additional term lah. Okay, yes, when we want to find the eye, we have to specify about which axis, correct? So when we do this x, we have to say about which axis. So for this case, I'm finding ixx equals to 1 over 12 BD cube, okay, which is this case, 1 over 12 BD cube ixx. But now I don't want ixx, okay, I want igg. Okay, so igg is basically ixx plus this area times the offset distance square. Okay, so you can still use the 1 over 12 BD cube. Okay, so this would be D, this would be B lah. Okay, you can still use this 1 over 12 BD cube, but you have to add an additional term here because the rotation is no longer along the centroid, it is somewhere away from the centroid. Okay, so igg about this axis, okay, will be this expression here. Okay, I hope you can see this. So likewise to circle also. Circle, let's say if I'm a circle here, I want to find kk, okay, ikk. Then how would you say? Okay, first you have to find out what is this distance here, what is this h value. Okay, then you will just use the simple shape formula, right? Pi d4 over 64 plus area of the circle times h squared. Okay, as long as there's an offset, you have to add this term. Okay, that's the moral behind the story. Okay, yeah. So let's look at a shape, a complex shape lah, huh? Let's look at the L shape again, and this time I'm going to draw a little bit more properly. Okay, and let's cut at the horizontal side here lah, like this okay. So this is your rectangle 1, this is your rectangle 2. Okay, if my x-axis and y-axis is here, okay, so this is your x-axis, this is your y-axis. So the same thing, we have to find the centroid first, right? So you will be given the dimension, okay, the side and the height, all the different dimensions, and you will know that the centroid of rectangle 1 is here, the centroid of rectangle 2 is here. Okay, so you have to go and find with respect to y-axis, with respect to y-axis, this would be x1. Okay, and for the second rectangle, this value would be x2. Okay, the individual rectangle centroid. Okay, and we also need to find y bar lah. and y1 and y2 lah. So y1 and y2 is like this. Okay, so this would be y1. Okay, no, sorry, this would be y2. Okay, this would be y2, and this will be y1. Okay, you always have to remember it is the distance from the x-axis. Okay, it cannot just be the half the height, it has to be half the height plus this. Okay, so that is your y1. Okay, and we will then proceed to find your x bar and y bar lor. So let's assume that we just need to find our y bar. Okay, let's say the whole shape, the centroid is here, this location. Okay, your y bar is this value. Okay, so proceed to find it using the formula sum of area times y bar equals to sum of individual area times its individual y. Okay, so to put it in the formula, it will be a1 y1 plus a2 y2 over a1 plus a2. Okay, with the values given, the dimensions given, you will be able to find these values. Okay, then you will obtain the y bar. Next, the question will typically ask you to find I about the axis of the centroid. Okay, which we usually call it IGG. Okay, where is GG? The GG is the line across the centroid. Okay, so this would be GG. Okay, imagine now the L shape is rotating about this axis here. Okay, IGG. This is yeah. So the complex shape I again is a combination of the simple shape I. Okay, so we remember we have two rectangles, right? Simple shape rectangle 1 and simple shape rectangle 2. So you can just loosely call this I1 plus I2 first. Okay, I1, this is I1 plus I2. Okay, now then we proceed to look at each individual simple shape. Okay, you have to know this value is the I of the simple shape. Okay, with respect to GG. Okay, it is exactly the situation whereby the rectangle is not rotating about its own axis. Okay, it is rotating about a separate axis, which is here. Okay, if it wants to rotate about its own axis, it will be rotating about this line. But the thing is that I1 now is not rotating here, it's rotating here. So we need to find a AH square. Okay, the H is how far away its centroid is from the whole shape centroid. Okay, so it is this distance here. How far away are you from GG? Okay, so we call it H1. Okay, likewise, because the rectangle 2 is supposed to rotate about IGG, about GG, so it is also, you also need to add a H offset here. We call this H2. You have to find this value. Okay, how far away is the individual centroid from the GG axis? Okay, so in formula terms, you will then write this way. I rectangle 1 will be 1 over 12, the B of rectangle 1 and the D of rectangle 1 cube. Okay, for this case, this would be D1, this would be B1. Okay, plus A1 H1 square. Okay, H1. This one you have to find. Okay, it's basically Y1 minus Y bar. Okay, y1 minus y bar, you will get this distance. Okay, And for rectangle 2, 1 over 12 b2 d2 cube. Okay, so for this case, the d2 is this side here, d2. b2, bravo 2 is the long one, b2. Okay, plus a2 h2 square. h2 is basically y bar minus y2. Okay, you will get this height difference. Okay, a1 of course is b1 times d1, a2 is b2 times d2. Alright, so this is how you will find the overall moment of inertia for this shape when it is rotating about its own, the whole shape's centroid axis. Okay, I can extend it to, okay, I can mention two more things. For this rectangle case, imagine now, instead of a combination of two shapes, right? Now you are talking about big rectangle minus small rectangle. Okay, meaning is A1 minus A2 lah. Okay, your y bar you can proceed to find. Okay, you can still do the same thing to find your y bar. Okay, and it will be about around here lah. Same, it is the same problem, so of course then the answer will be the same. Okay, so this one will be your y bar. You can proceed to find the centroid to find y bar. After that, okay, your IGG, your IGG, you have to remember, because it is big rectangle minus small rectangle, it is no longer I1 plus I2. It has to be I1 minus I2. Okay, so this one is a negative, so you have to have this minus. Okay, and what's even more important is that when you expand to something like this, right, you have to be mindful. I1 again is the same thing, b1 d1 cube plus a1 h1 square, right? Okay, you have to make sure there's a minus sign before all these terms here, the I2 terms. Okay, so it's minus 1 over 12 b2 d2 cube plus a1 a2 h2 square. Okay, this is very easily missed out. So my advice would be always put a bracket, okay, to put all the terms that relates to rectangle 1, and put a bracket and put all the terms that relates to rectangle 2. Then after that, if it's a subtraction, you put minus. If it is an addition, you put plus. That's it. So it will look like this lah. Okay, you compare this to this. All right. Okay, one more case, which is a bit simpler one. Don't worry. Okay, imagine now you have a T, and you decide to split this. Okay, this is a symmetric T lah. Okay, we symmetric about this axis. Imagine your question is about this T. You will see that the individual rectangle centroid, right, actually lies along the same line as the whole shape centroid. Okay, so GG happens to be in the same line for the individual shape centroid. So this is a big bonus. Okay, for your case, your IGG here, this is rectangle 1, this rectangle 2, is still 1 plus 2, right? This time, because, okay, maybe I just write out everything, okay, and you will see what I'm talking about. So it's the same thing, 1 over 12 b1 d1 cube plus a1 h1 square plus 1 over 12 b2 d2 cube plus a2 h2 square. This is the expression, but you realize that the h, the distance of the individual rectangle centroid away from GG, is actually 0. Okay, H2 also, H2 and H1 are aligned with the whole shape centroid, so H2 also 0. That's why for this kind of case, is a bit simpler because you only need to have these two terms. Okay, because their centroids are all aligned together. Okay, compared to this one, GG is here, but rectangle 1 centroid is here, and rectangle 2 centroid is here. So they are in two totally different locations. So you need the H1 and H2. Okay, I hope you understand and take some time to practice. All right, take care.